My name is Victoria Husser. I'm your moderator for all today's lecture for Core B. Before we start our first lecture of today, I'm going to share my gratitude to the official partners of AIT Summer School 2024, the leading IT companies NeuroForge and NIX. Also, we are very grateful for the help of other value partners, SoftServe, EPAM, and Intima Software. Such companies as Lviv IT Cluster, Dove IT Ukraine Association, and Marketer are our main informational partners, and we're also very grateful for their help. Also, we are sending our thanks to other participants, companies Global Logic, Docs, Sigma Software University, UATINS, Alex, CHI Software, Viewpoint AI, Machine Factor, and Neurons Lab. Moreover, we would like to mark the support of the Ministry of Digital Transformation of Ukraine, the Ministry of Education and Science of Ukraine, the Lviv City Council, and the Lviv Regional Military State Administration. Also, a little reminder for our participant. If you want to receive a certificate in participation in our school for ECTS credits, it is necessary for you to attend more than 80% of classes. Also, if there happens to be an alarm, I'm going to stop the speaker and this meeting to inform every one of you. And if you will be endangered, I hope you go to a safe place, for example, shelter. If this alarm happens to be too long, then we are going to postpone this meeting, and the next date and time of this meeting we are going to tell you in our Slack channel or maybe in WhatsApp. Also, before each meeting, please join an appropriate Slack channel for today and according to the lecture. So for this lecture, you have to join Slack channel. Its name is 0704 Core B 1000, so that you can participate in discussion with the speaker or other students, because as you know, Zoom chat is disabled. It is our main rule of this school. So the first lecture of today is retrieval augmented generation in the new processing, and the speaker of this lecture is Oleh Sannikov, the mobile competency manager at Alex company. So Oleh, I gave you the right to be the co-host of this meeting. You can start it.
Okay, good morning and thank you. Let's probably start. Good morning, everyone, and the topic for today is retrieval augmented generation in news processing, and we'll be talking about track. How could it be applied to to get a context on the news. But let's start with a short intro. I'm working as a competency manager and software architect at Alex. Also, I'm doing data science researches, and this is one of the projects that I made with my fellows. So the idea of the lecture today is actually share our experience and give you some insightful moments, maybe. So let's start. Let's talk about motivation. Meanwhile, if you have any questions, I think write them in Slack or in Telegram. I'll be stopping, no problem. Or we can do it after the lecture. It doesn't matter. So what is news? First of all, we have to find out what is it. It's some piece of information which is reported, and usually what is typical about the news that it is spread through different channels, so we can find it not in one place but in many places. And if you talk about the distribution channels, it could be whatever, TV, internet, radio, newspapers. But today we will be talking mainly about the internet, about actually about Telegram channels in particular, but it is not limited to it. It's just this particular case. So what kind of attributes does the news have? It have the types. As we said, it could be informational, it could be educational, it could be urgent or non-urgent. It could come from different sources. And of course, it is related to some events, persons, and objects. Yeah. So the important task of dealing with news is, especially for today, is fact-checking. And fact-checking is in other words, finding whether the news are true or maybe not so. And how can we do this? So first thing is which comes to the mind is how this particular piece of information is connected to other news or other facts which could be found on the internet. Second thing is let's say verification of a source, whether it's credible or not. And third part is check for manipulation techniques, which were probably used in this particular information. This is a separate topic, but there are many metrics to find out whether the news is a manipulation or not. It is not covered in this presentation, but it comes along with it. So this particular solution, this particular project that we are discussing is just like maybe, let's say, a neighbor project to a project of detecting manipulations. Yeah, so we probably want to approach this fact-checking with AI. And this is also could be done in several ways, and probably the most obvious way which could come into mind is model retraining. Model retraining is kind of good thing. So our model will know everything about what we ask it, because we're talking about large language models. But it could be expensive process, and it also takes a lot of time, even with up training, which certain models allow. It is kind of overkill to make these retrainings on regular basis, especially when it comes to some hot topic which develops quite fast, and there could be like hundreds of events of new news coming in a day. So it appears not feasible to do retraining at all. Another option is function calling, or how GPT for all employs it. It is basically going to the internet to find some relevance. If you talk about GPT, if you talk about function calling, this particular, let's say that we are talking about a callback that our model has to actually to clarify if it wants to know some extra information. But it could not know that it wants, in fact, because from the context it has, it could be something like enough, and it will work with just the results it has. And second option that we actually discussing today is retrieval augmented generation, and Well, the idea of it is actually is to have a database of information of let's say news data set, which is gathered from some let's say reliable sources for a given context, for a given reader. Vectorize this information, then do vector search, find some similar results, which could be relevant to the piece of information we are looking for, and then supply it to LLM. So let's say vanilla, the most generic retrieval augmented generation architecture looks like this. Let's say we have a user who asks a question, and this question is as I mentioned before, it is converted into embeddings. Relevant documents are extracted from the vector store. Then this question is combined into a context of a prompt, and we proceed with the prompt to LLM. There are many options regarding the toolset, how this could be implemented. Let's say there are really huge amount of different databases. For this particular project, we use Face, but there are also Charm, LensDB, and so on. They all work. They all good. Face is developed by Facebook and is sort of an industry standard. So we use it, but feel free to use what you want. Everything is orchestrated by LangChain. Work with LLMs, work with embeddings, just do it. I think it's industry standard as well. And we have to make a choice of LLM. First of all, what things should be considered? The first thing to consider is that LLM should be instruct-oriented. It should not hallucinate a lot. So the lower its hallucination rate, the better. Of course, shall consider performance and price. When it comes to when we talk about GPT-4o, it's cool. It actually, due to its nature, it doesn't need RAG in general case at all, because it can go and search for the information it needs, but it's kind of costly. And if you want actually to monitor some specific news sources, we will have no control over it. No that much control. It actually will influence the results that we want to see. So in some cases, it could be really useful to have a LLM which has a really small context on the information that on the news that you want to work on. So there are no interference between the knowledge of LLM model and the things that you want to talk about with it. And the role of LLM, as it becomes obvious, is to summarize, to do some, let's say, aggregation of the facts, interpretation of them, and then transforming it to some human readable results. Performance is also a point to consider. It is possible, and it is, let's say, as I said, it could be one of likely scenarios to use self-hosted LLM, but then you need the hardware which will allow for it to run smoothly. we were experimenting with Mistral. And let's say it's possible to run Mistral 7D without GPU, but it's so painful that it will never work in any production. We could also use a quantized model for this purpose. And yeah, so there is a space to experiment. And another important point to mention is that the model should understand the language that is used for the news. So we know that there are some models which work not so good with Ukrainian language, and if you want to orient on it, then we have to take it in account. So the first step for our task is, in fact, is a data preparation. It could be done in any way. For example, on the left we have a Telegram client, which is connecting to Telegram and fetches the data from some channels. Or we can do it with the files that we saved somewhere on a drive we have supplied from other external service, or we can do internet scrubbing with Beautiful Soup or any similar library. Then the data is split into chunks. This is an important part of the task. So after that, after it was split, it will be put in a vector store. And from our observations, there are many different embeddings which could be used for this task. If you work with OpenAI, we were getting some better results with OpenAI embeddings, but again, in contrast to the open source models from Hugging Face. But again, it's a question of a price. Another important thing about considering LLM is the context window size. So it could be not an issue at all with the latest model when we have hundreds of thousands tokens in a context window, or even 1 million for Gemini. But when it comes, for example, to GPT 3.5 or some older models, smaller models maybe, it could be a problem. Because what we are doing, in fact, is populating a context with relevant information to make model think about what we supply to it. And it is easy to overflow this window size, especially when we are doing some tricking and fine tuning and doing iterative prompts. But with a straightforward implementation that we'll be looking into today, it's not a problem. So 3.5 context size is enough, but it's an important thing. Models should be tuned, as I previously mentioned. So if we have control over the model temperature, we don't want it to be creative. We want it to be precise because it's news. We want to have as much truth as possible. And as I mentioned, it is possible to use self-hosted models like Mistral, Oleh, or Gamma. And quantize the model. Try to quantize to save some CPU power. How the results can be tuned? So the straightforward approach, as I described, we get the question, we get the news, we find some relevant news in our vector database, and we ask the model. It is not always that model returns the result that we expect from it. And at least two things we can do to improve the results. First is few-shot prompting. In fact, few-shot prompting is applying an example or several examples how to respond to a question, so it better understands how to perform a task. And another thing is to do clarification. So when the model responds, we ask it for some. We ask it again, simply. What could be used for what could be used for implementing this this approach and rapid prototyping of the results. So again, there are many libraries. At least two are straightforward and simple: is Gradio and Streamlit. And they're basically they're almost the same in the complexity of the usage. I'll show an example with Streamlit. And now we'll go to demo. So to see how it works. Let's go. Where's my Visual Studio? Hold on. Oh, yeah, you have it. Good. So let's take a look a bit for functional parts of our demo. The first part, as I mentioned, is a Telegram channel parser. We use Telegram client library supplied by Telegram, and what we do simply is maybe it's worth showing, but let's say that you can create an app on Telegram. Enter your phone number. Well, it's pretty straightforward. You just go there and enter your number, register your app, and then get your ID and hashes, which we'll use which you will use for the client. Here is a channel name, which is a pretty popular Telegram channel for news grabbing, and it's super vibrant. Here we specify the minimum date we want to start grabbing our messages, and then we do a loop which is doing the job. I think we'll be not spending our time on this. I'll just say that, let's say, if you put some play date, so it will run fast. Oh no, this is not it. It may ask you for a token for authentication, but not in this case. And we've got a Parquet file, which is kind of small. I specified the 1st of July, so there are quite some news from that moment. And yeah, and here we save the collected data to Parquet file. Then the next part of it of this task is to actually what shall we do? We shall import our data, our grep messages into vector database. As I said, that we use face for this task, and the code in front of you is actually doing the job. I think we'll not go into the details. You'll be able to review it later. But this task takes some time, and for the like long periods of for large databases, it will take a while to import. And then when we have vector store, we can actually go to real things. So what is the central thing here? Actually, yeah, I think it will be a bit hard to get a code from scratch. So I'll focus maybe on some things that we supply. We create a model. We create embeddings model, which is Hugging Face embeddings in this case. And yeah, we load our vector data, and then what happens is in fact that we configure our retriever, which like find 20 similar articles, and then we supply. We do a search to find relevant news. And then we create a long chain with a prompt to our model. GPT-3.5 Turbo is used in this sample, but it could be any model. Long chain gives seamless opportunity to switch the models, but what you have to keep in your mind is that prompt will have to be adjusted. So another central thing here is a prompt, which actually defines what model will say. And another thing to highlight is probably that we are giving format instructions to a model. So we have a response parser. Where do we have it here? Helpers, which has a defined structure of how the response from the model should look like. And let's see how it works in life. Do we have it? I think it's here. Yeah. Well, I'll show you briefly how the Streamlit app looks like. It's pretty simple. Well, it's pretty messy, but in fact, it just loops iterating through a response, through a JSON response, and filling the fields. Let's see how it looks. And we can ask something that we know that happened recently. Well, I closed my Telegram. This is the thing that really caught my attention. What is happening? We can see in the console that our app has found some similar news in our vector database, supplied it to a model, and this is the result that we get. So we have a summary which is quite relevant. And yeah, and there is some analysis which could give us some hints about what happened. This is not one of the things to mention here is that models are not consistent. And that's probably one of the biggest problems here with RAGs and with models, that we cannot always be sure that that model returns all the information we want from it from the model, and yeah, and how much information we will get from there. Here we're using really small amount of data in our packet, so it's just very recent news. It's kind of 80 kilobytes weight, and I can use another set of data. Let's try to do it, which is quite bigger. The same question. Let's try. Something's happening. And with this bigger data set, we've got much more information from the model. We've got more related persons. We've got vice minister and some other candidate. So the model, in this case, the model has found some additional information and even suggested us some replacements for the prime minister, which is also true and also was in the news. What another probably pitfall of this approach? So our vector database should have some relevant information. And if we ask it something like really impossible, which is really not related to the information it could produce us some really strange things. So if you say that something like this, let's see. So some information was found, but our model thinks that that this event really happened, and Trump was discussing a plan about Ukraine and Russia, which happened in fact, but it has nothing to what we ask it about, and this could be mitigated. This could be mitigated by prompt tuning. We could explicitly say to a model that please don't give us any results if you think that the result is not relevant. But again, it should be tuned, and it should be like tested that it works. And it could change. It could dramatically change depending on the model. And instruct-based models work here better. So yeah, let's get back to the presentation. As I said, sufficient information is in vector database is crucial. With another data set, I've got some sort of this result because the database was not updated and it was so model were giving a context which is not relevant to what we are interested in. Yeah, and here we see that result that we've seen just recently. So here we populated our vector database with the fresh data. Another thing, as I also said, that prompts are very important. During this project we were trying different models and even slightly changing a model. So it's like going from 3.5 GPT one revision to another, leading to the results and required us to look into prompt and try to adjust it to get the results we expect. Another findings is that, as I said, commercial embeddings may work better than open source. Context size is important. Later models are more prone to deviate with the results. So with the recent better models, we get more consistent results usually. And another thing is that it was not shown in this demo, but it is definitely possible to improve an accuracy of the results by asking clarification questions from the model. Yet, if you do too many iterations, we get the results blurred. So the model gets adrift from what we asked and starting to think about not relevant things at all. So this is one of the points that I'm not showing you prompt iterations in this demo. It's just a straightforward one short prompt. And also, I'd like to share useful materials which could be used to experiment on RAG and on well, maybe on use classification and discovery as well. So those links are mostly dedicated to RAGs, and especially if you want to go deeper, you can think about knowledge graphs, how they work to build really, let's say, trees of connections between the news. And I want to say thank you to my colleagues, which were working with me on this project. And yeah, that's it. That was a pretty short lecture for today, but maybe you have questions and we can discuss them.
I see that right now we don't have any questions. Maybe we could wait for 1 or 2 minutes so that our participants could write something. If there won't be any questions, I believe we can finish this lecture.
Okay, anyway, I will share the materials with you, and I'm available in Slack or in Telegram, so we can ping me back and we can discuss this topic. Okay, so it seems that we don't have any question. As I said, feel free to ping me, and thank you. Thank you for your time.
Thank you very much for participating in our school. We are very grateful to see and hear you today. I hope we have another collaboration in our next AIT summer school. And I wish you a nice day for today.
Thank you. Wish you nice days all.